The Leaning Menace of Pisa, a tower in trouble, the Leaning Tower of Pisa. You've all heard of it, right? It's super famous, an icon. But back in 1990, this amazing structure was in serious trouble. It wasn't just leaning a little bit anymore, it was leaning a lot, dangerously so. Engineers and history buffs were holding their breath. Something had to be done, and fast. The world watched, wondering if its beloved tower would survive. It was a monumental challenge, a true test of ingenuity. So how much was it actually leaning? Get this, a staggering 5.5 degrees from vertical. That might not sound like much for a small object, but for a massive 56-meter-tall marble tower weighing 14,500 tons, that's a huge, terrifying tilt. Weighing the options and the tower. First steps to salvation. So the big question was, what could anyone possibly do? The engineers, bless their clever minds, got straight to work. They launched a massive investigation. This wasn't guesswork. They drilled into the ground, taking soil samples. They built scale models of the tower to test ideas. They ran complex simulations on computers. They needed to understand every single detail. How was the tower behaving? What was the soil really like? Only then could they dream up a solution. It was like a giant science experiment with a priceless artifact at stake. And what they found out was pretty darn alarming. The tower wasn't just leaning, it was on the very brink of collapse. One researcher crunched the numbers. His estimate? The factor of safety was a tiny 1.07. That means the soil could only take about 7% more stress. Imagine standing on a plank that's about to snap. It was that close. A real nail-biter. They needed a quick fix to stop it from falling immediately. Anchors away, or not. A setback on the road to straightness. Those lead weights were a great first aid kit, but they weren't the final cure, not by a long shot. They were bulky, unsightly, and well, temporary. The engineers were hunting for something more permanent. One idea that came up was using deep anchors. Think of them like massive tent pegs drilled deep into the earth. The plan was to install 10 of these powerful steel anchors. They would be sunk into the stable soil beneath the north side. Then, they'd be tensioned to gently pull that side downwards. It sounded like a solid plan, a robust engineering approach. So, they started the work to install these 10 deep anchors. Digging for victory, the underexcavation breakthrough. The engineers were stumped but not defeated, not these guys. They needed a new, even more ingenious plan. And they found one. It was called underexcavation. Sounds a bit like underground archaeology, doesn't it? But the idea, when you break it down, is beautifully simple. It means very carefully, very precisely, removing small amounts of soil. Where from? From underneath the north side of the tower's foundation, the side that was sitting too high. It was a delicate dance with dirt, a high-stakes game of Jenga, but with a priceless monument. Why remove soil from the north side, you ask? Well, that was the side that hadn't sunk as much. The tower was leaning south because the south side had sunk more over centuries. So if they could gently encourage the north side to settle a tiny bit, the whole tower would rotate back towards the north. It would become more upright, reducing that dangerous lean. It's like letting a tiny bit of air out of one side of an overinflated tire. A straighter future, still perfectly Pisa's success and stability. With testing complete and safeguards in place, it was time. In 1999, they began a preliminary under-excavation trial on the actual tower. Nervous? You bet they were. They drilled 12 initial holes under the north side. Slowly, carefully, they removed a small volume of soil, and then they watched and waited. Over 5 months, the tower responded beautifully. It tilted back towards the north by about 90 arcseconds. After a few more months, it settled at 130 arcseconds, around 0.036 degrees. It worked. The under-excavation method was viable, huge size of relief all around. So, in February 2000, the main event began, full-scale under-excavation. This was the big one. Over the next year, engineers meticulously drilled 41 holes. They worked with incredible precision, removing soil bit by bit. In total, they extracted about 38 cubic meters of soil. Don't forget to subscribe to Ace Ed for more interesting videos.